Hi everyone, welcome to this Git and GitHub demonstration that we're going to do for you today. So this is really going to be a small demo on how to set up things and work very basically with them, because these are two useful tools that can really help you in your project that we use every day here, the people from the Data.trek team. And yeah, so let's get down to it and see how it goes. So the document that I'm going to follow here is available to you. It's on the Ran.données Data.trek GitHub profile that you can find at just github.com/Ran.données Data.trek. And then it's the Data.trek 2020 repository. And you can see here that it's the commands that I'm going to show, and you can just follow along, try them on your own computer, and you can try to follow any ways you want, like this. Okay, so the things we're going to show, in fact, is two different things, is Git and GitHub. These are kind of two separate things. First, Git is the software that we install and that you have on your computer. It is a way to organize your workflow that is especially efficient with code because it allows you to structure it in a way that is reproducible and like kind of building blocks that you can use. So the structure is kind of like this, where like each changes you make becomes a commit, like a point in history. I'm going to explain to you later on how it goes, but you build on this and in a way that is structured, so that it's linear. It works like this. You can go back and see like how your repository was before you made some changes, and you can go forward like this and merge things with people you're working with. So this is where the GitHub part comes in, because GitHub is the platform that is online and that we use to collaborate, and everything is very efficient. Yeah, so today we're going to cover those two basics. We have this lesson that is divided in a few categories. And first, we're going to talk about how just to configure Git on your computer. So here on this computer, we are using Windows, and on Windows, we had to install something that is called Git for Windows, or to use the Git Bash program too. We will post a link in the description on how you can install this for any platform. And here is a very good thing made by the Software Carpentry, when we see installations on how to install everything, like for Git here. So you can go check that and see for different platforms how you can install and get things working for you. So now to start the lesson, we're going to do the first configuration part. So here, and I'm going to do the demonstration in the terminal because this is what we need to use. On Windows, it's recommended to use the Git Bash program, which you can just get this way here, and it looks like a terminal like this. On Mac or on Linux, you could use any kinds of other terminal. On Windows, we do recommend that you use Git Bash like this. So the first thing you need to do when you try to work with Git is, first, well, if you want to go on GitHub, you will create a GitHub account and you will have a username. So you want to have that set up so that your computer knows what your username is. So we do this by this following command, which is just git config. We need to put -- global. So first, like the first command git was because we refer to the Git program, then a space in config, it tells us like what I want to do, kind of. And afterwards, with the -- like this and a command, we provide like an option. So it's going to be global, so that it's enabled for your whole system, for your whole computer. You only have to set this once when you set up, and afterwards you can work very easily without doing this. And then we use user.name, and we put the username of your GitHub account that you're going to be using. In this case, we're going to use the Data.trek account, which is Ran.données Data.trek, like this. And you can close it like this, and now you just press enter, and now it's run. So your username is set. The second thing that is important is your email address associated with your account. Is this way because if you ever change your username, you still have the email address that is associated with your GitHub. So it's important to do also. So we still do like git config, then global to have it everywhere. Now it's user.email, and we put the email associated with it. So in our case, it's name with one less m. The Data.trek, gmail.com, like this. So we run. Okay. And the last thing we want to do, oh yeah, first, one thing, if you want to show, to see that this works is okay, is you can just do the git config list like this. And we have a lot of things here, but yeah, we can actually see the user email that is being used in the user.name. So you can see this way that you have made a mistake, and that it's really what you're using. So let's get out of this. Right now, I press the Q button to get out of that thing. So, okay, now let's get back. And the final thing for configuration that we want to do is just to have our computer store our password, because else every time you try to do GitHub related operations, so online, it's going to ask you for your GitHub password, which is annoying, but there's a way to have your computer remember it. So it's just going to be git config global as before, and now it's the credential helper, credential.helper, and without dash. And now we do the cache, so it's going to cache it and you remember it like this, so you run. So next time that you're gonna enter your password, so the first time that you try to do something is going to ask for your password, but then now that we've enabled the caching of the credential helper, it's going to remember it. By default, I think it's for a few minutes or whatever, but you can set it to whatever you like with the git config --global credential helper. Now we're going to say that it's trying to write down cache timeout. So this is just an option that is going to remember, and we say the number of seconds that we want it to be. So let's say we want it to be an hour. We can just put not this is a mistake, but I'm going to put like 3060 seconds for an hour. There we go. All right. So this way is going to remember my password for an hour. And in fact, I just made a mistake, and it has to be credential that way. Those things always happen when working with Git in the terminal, so it's perfectly normal to make mistakes. So there you go. So now this is working, and it's going to remember my password for an hour so that I don't have to write it down every time. Okay, so coming back to the repository right now, we're going to move on to the next section, which is just going to be how to start a repository, both in GitHub and link it to your own computer, so locally. So right now, the easiest thing to do to go back to your profile is just click here on the GitHub logo. You can also go to github.com, and it's going to get you where you are to your profile. In our case, we're on the organization profile here, the Ran.données Data.trek one. And what we do to create a new repository is just click on the new button here. And it gets us, we have to add a repository name. So we're going to name it Git demo. And you can add the description. It's always a good thing to do because your repository can be public and will mostly be public on GitHub. So a description helps people understand what your repository is. So it's a good idea for your own projects. And I'm just going to say that is a basic demonstration. Like this. Okay, so we can choose if your repository is public and private. In this case, we're going to put it public. Most of the things on GitHub are. This just means that people can see it, and it's, we believe, a good thing because it allows you to share your code, and it allows people to be helped because they can look at things you've done, and you can look at things that other people have done. So it's what we're going to select here. And the next step is we have a few options, and it says that it's options for if you're to skip them if you're importing an existing repository. It's not our case. We're creating a new one. So we do want to have a README, which is something I'll show afterwards, that helps giving more details about your project. Whereas we're not going to add a gitignore. We don't need it for now. And license here, it's a good thing to have a license for your project. So I'm just going to select one that is the MIT license, which is good in academic context. Having a license for your project is good because it kind of defines how people can use your code. And the MIT license is one that allows people to reuse your codes as long as they cite you and what you're doing. So it's a good thing to add one. And in our case, we're going to use this one. All right. So then I'm creating the repository. And we see this. So we see both the README and the license. So the only two things that I created. And you see like the README, in fact, is just what is being shown here. So it's a nice way to have a bit more information about your project and to show some details and everything. So by default, it's only your title and your description, but you can also add more things afterwards. And it's actually what I'm going to do, and I'm going to make some changes here. But now that we have created this, our own GitHub repo like this, the thing that we want to do is download it and have it on our computer. So the way we can do is here we have an option that's clone or download. And we can see here, so the option, basic one is HTTPS, just the thing that we want. So for now, I'm just going to click here to copy paste this address here, which is in fact the address of the repository. And now we're going to go to the terminal. So in my case, on my computer, I want to put it in this folder. So I'm just going to right click and do start git bash here. So remember the git bash program I just showed. Now I'm going to start just a new time here. And now the command I'm going to use to download is git clone, because it says that we are cloning the repository in this case. And I'm going to just copy paste the URL that I had done previously, like this, and we enter, and now it's been downloaded, and I can actually see that it has been downloaded on my computer here. If I click, I can see the license and the README of it. So now, now the repository is on our computer. The thing that we have to make sure is that it has a remote URL so that it knows where to refer, like on GitHub and everything. So the command we can run for this is git remote -v. Oh, yeah, of course it doesn't work. And again, mistakes are normal in this case. So the thing that happened here is that I'm just in my Data.trek folder, but now I cloned my repository into a subfolder, and I need to change my directory to go there. So it's with the cd command, bash like terminal like this. So cd Data.trek, no, like this. I called it git demo. Right. So now I'm here, and I can see master here, which is when we're in Git project, it says that I'm on the master branch. So that is perfectly normal. It's the default name for the default branch. In fact, it's always going to be the master one, we say. And now I can check what I wanted to do is just git remote -v like this, and kind of for verify, and now we can see the URLs of the origins of the remote one on GitHub, and we can see that it's good. We can see that this is the right one. So that's just how you can set it up on your own computer.
Okay, so now let's move on to the next commands that are the ones that you actually need for your daily Git workflow and how to work with things. So let's go back to the terminal and maybe make this a bit bigger for you guys. All right, so the first thing command I usually run is git status, because I'm already kind of lost and I don't remember where we are at. So git status like this tells us the status of our Git project when we run it in the Git repo like this one. And when we see like we have the little master header like this, just make this bigger. All right, and it tells us basically on branch master, so which branch you are on. I'm on the master, which I told you is the default branch. And then it tells that the branch is up to date with origin master, so the remote one, the one on GitHub. And then that there is nothing to commit, working tree clean. So basically, there is nothing to do. Okay, so well, the thing we're going to do now is actually make some changes and have Git record those, because it's what Git is good for. So I'm just going to go back to my documents, which was in here. So this is the repo I was showing you. And you said before that I had a README file like this. So I'm just going to open it up with the default, well, with Atom, which is a good text editor that we like to use. And I'm going to actually make some changes to that file and try to have these put up on GitHub so that someone else could see it and make other changes and stuff. Okay, so Atom is open like this, and we see here in this case, let me just remove maybe the other things. Yes, it's confusing. All right, so this is the file that we had before, the readme.md, and just a Git demo, basic Git administration. And if we go back here to the GitHub repo, it's actually just the same thing as there was here. So I'm going to make a change to it, just adding a line, and now a new git change, whatever, like this. So I'm just adding a line of text here, and now I'm going to save it. So my file has been updated on my computer now, and I want to have this change in push online and in a structured way as what Git allows us to do. So now if I just run the same command as before, so git status, now it's changed. And what I see is that there are some changes in that stage for commit. And it said that I modified the readme.md file. So this is actually the thing that Git does, is it tracks the changes that you made. So that's why it's called a version control. So it tracks like the version of the files that you have been using. And now we want to have that file been taken care of by Git. So we will use the git add command. So with this, you select the files that you want to be added to the Git tracking, and the changes that you want to kind of track or to take into account that you want to add to your project. So I run git add, and now I run the name of the file. So just readme.md. I run this. It hasn't changed. If I call git status again, now it tells me that changes to be committed, whereas before they were not staged, and now they are to be committed. So it's the way that things work in Git is you kind of do this a few steps process where first you have changes that you make that are not taken care of, you add them, and then they're ready to be committed. Commit to me kind of looks like comment, and it's kind of a nice way to see it, because a commit is a change that you like comment to structure things. And we're actually going to do this with the git commit command. And now I'm also going to use -m because I'm going to put a message for this. And now I need to put like a message that describes what I did. This is a message that is going to be used by me or like your collaborators. So you want something that is clear, that is useful for people, and I've described the changes that you've made. So here I might just say that I've added a new line to the README. So add in a new line to README like this. And I can just enter this. Now it does mean it's changed. And then when I run git status again, I see a few things. So now it tells me on branch master, there is nothing to be committed or whatever, but it says that my branch is ahead of origin master by 1 commit. So like commit is really the thing that I just did here. And it says that I have like one more, I could do others, but it also tracks the fact that I'm ahead of the remote branch, the one where we were before. So right now, what we wanted to do is then to have the commit on GitHub so that we could see it here in the same place, because if I just refresh this thing here, well, we cannot see the line that I've added. So going back to the terminal, the thing we're going to run in this case is first, okay, so good thing always is to check if there are any changes that have been made before. So you can do that with the git fetch command like this, and then run again git status, and it doesn't change. It's exactly the same thing as it was before. I'm actually going to come back to the git fetch command, but in this case, we know that there wasn't any change because we're the only ones doing changes in that repo. So right now, if I want to send it again, so now it's in my local, and I want to put it into the origin, into GitHub. So I run the git push command. So we push it online, and it's git push origin, and my branch online was on master too. So git push origin master like this, sending it. And this might be the time where it's going to ask you for your password if you're not logged in. In my case, I am, because I use Git on my computer at times, but you might have to put it one time. But then if you have enabled the credential helper, as I've seen before, you should not have to do it again. Okay, so it worked. And now if I just go back to GitHub and we can see that there have been a change. So in the README right here, we can see the line I've added, and it's also been added right here. So we can check the commits history. And in this case, well, there's just the initial commit. And when I added a line like this, so this is pretty useful. one thing that we can do too is go the other way around. So instead of creating something locally, we can create it on GitHub directly and try to get it on our computer afterwards. So I'm just going to do that maybe, and like I can edit the file with the thing here, and I'm going to add a new line and a line that was added on GitHub. There. And then when you commit the change, you don't have to do the git add, git commit, and git push thing. It's already made here. So you have to put your commit message in this thing here. It suggests just by default to have the update read needed MD name. So let's just say that for now. And then I want to commit directly to the master branch. It's the default option is the one I want to do right now. So let's commit the change. And now there's the new line that was added here. And now if I want to add it on my computer, the command we need to run, if I come back, oh, I just made a mistake. I didn't want to open a new one. I wanted to stay in the same one. And now if I rerun git fetch again, see, there's something here. It says from GitHub, Data.trek, git demo, master to origin master with an arrow like this. This kind of tells us that there have been some changes that have been like, that are not in Git's memory. So when I run git status, now it's telling me that I'm behind origin master and that it can be fast forwarded because it's just a new change that doesn't create any conflict with what we have right now. So if I want to have the change, what I need to do, in fact, is the reverse of what I did before. So instead of push, it's going to be git pull, still with origin master, and this. And now it's changed. And if I run git status again, nothing there. If I go check on the file on Atom, yep, you see it's already there. So I've successfully created something locally, pushed it to GitHub, and did a reverse, created something on GitHub, and afterwards got it on the computer. Okay, so the next thing I want to show to you is how to use branches on Git and GitHub, because it's a very important part of like the structuring thing that Git and GitHub allow, and that is very important to like collaborate with people and other stuff. So if we look at this thing that I showed you before, we can kind of understand the concept of like branches. It's just for now we have been on like a master branch where we have made some commits. So imagine like dots that were made here, and branches are useful in the case where you want to make some changes, but you're not sure really how much of a consequence it can have to your files, because maybe it's going to break your code, maybe it's going to do something that you're not exactly sure of, or maybe it's because you collaborate with people and you want to do something new and you don't want to work on the same thing as someone else. So this is when a branch can be useful, because you create a new branch like this and put some commits there. You can submit a pull request. So like you're asking like to pull things back on master. People can review, discuss things, and then you merge the changes back into the master where they were before. So the way we do this in the command line, going back to this, first I'm going to just look at what the branches are in my case. So I'm going to run the git branch command. Here it just says master. Okay, it's because I only have a master branch. I can also run git branch -a, and now -a is for all. So I'm gonna getting all branches. So I can see that there's a master, there's the head, so like the main one where things are pointing, the origin master, and yeah, in this case there's the origin master. So it's useful. I know that I don't have like more branches than this, but right now, I want to create a new one, let's say because I want to make some changes that are, I want to develop some code or whatever, something like this. So I'm going to create a new branch with the same git branch command, and I'm going to name it dev. It's something that is often used for development. So just put it like this. And if I run again, git branch -a, I can see that now there is also the dev branch. But you see there is a little asterisk here around master. And that is because we are still on the master branch, as we can see here, it says. So any change that we would make here, in this case, would still be made on master, and any commit that we make on master, because this is the one that is checked in, as it's called in Git. So the thing we want to do is switch to the dev branch, and we do this with the git checkout command. So we check out the new branch, and we just run git checkout dev because it's the name of the new branch. And it tells me I've switched to the next one. Now if I run git status again, there you go. I'm on the branch dev, and I have nothing to do. This is fine. The branches are all aligned. So I'm going to add a commit on my thing here, and I'm going to say that comment made on a branch. There, saving again. So now if I come back to terminal, there, git status, I have to do again the git dance. So now it's telling me that I have a change, so I have to add, then commit it. So I'm adding. One way you can use if you want to add everything that you had. Remember before I said that we needed to put readme.md. This would work, but in case I want to put everything, you can just put a dot for everything that is in your repo, and this is also going to work. Now, if I go to git status again, it tells me that I just I've staged the readme change to be committed. So I'm going to put my commit. I'm going to say that I made a commit on a branch. There you go. And now if I run status, see, it tells me that there is nothing to commit, working tree clean. Remember before it said to us that we were either ahead or behind the remote branch? Is because in this case, the remote branch doesn't exist on GitHub. It's only locally. So if we want to have it on GitHub, it's the same command that we had before. So we're going to git push origin. It's the place where it is. And we say the name of the branch, so git push origin dev. So now we can see in this case that it's creating a new branch like this. So now if I go back on GitHub on our repository, we can, in the branches here, so by default, we always get to the master branch, the default one. But if you click here, you can see that there are other branches. So now if I go and check that one, I can see the new comment that I've just made, that it's been made here. So this is a way that you can make some changes like this, experience with your code, and you always know that you can get back to the previous state, to how it was, because right now, if I just came back to master like this, it's still the same. The change I made hasn't been made into master. If I go here, for instance, I can just see that there have been 3 commits in this case, but now if I switch to the other branch, we can see that there are 4 commits. So really, like the branches are independent things. They're not related for now. So it's very good to experience with code and stuff. But the thing that you might want to do is really merge the change and have it on your master branch, even if you made it into the previous one. So what we can do, the command that we use in this case, is going to be the git merge command. But first, if you want to merge, you need to get back to the base branch, so the one where you want to merge some changes in. So in my case, I've made a change into the dev branch, and I want it to be in the master one. So I need to call the git checkout again to change, and I'm going to check out master. So now I'm getting back to that one, and you see, as I did here, this line disappeared because Atom can live update the thing regarding the file. I could do it again, git checkout dev. Here it appears. And then I'm going to do it again. And there you go. It's not there anymore. And before we merge, I'm just going to show you another command that is useful. In this case, is the git log command. So this is just a way to see the commits that were made on your computer and everything. So when you run git log, you have something like this. And now I can see that I am on the master branch because it's the thing that is at the top here. And this is just basically telling me who made the commits. So the person, the date, and the commit messages. So we can see them with a way. These things are like the commit IDs that are unique to each commit and used to reference all of these. So I can see that the new one I did, remember I called that making a commit on the branch or something like this, is not there. Whereas if I checked out the other one, here, and now I call git log again. You see there's something new here, make a commit on the branch that wasn't there before. And yeah, so this is, we can see like the difference. So like the master, both my master and the origin one, the one that is in GitHub, are here, whereas the both dev branch are here. So what I want to do really in this case is just to, in fact, get the master here. So I'm coming back to the master one. And now I am going to use the Git Merge command because this is what I do. And I just call the name of the branch that I want to merge into master. So Git Merge dev. It merged it, and now we see that the command has appeared just here. And if I call git status, now it tells me that I'm ahead of origin. And if I call git log again, I can see that the master has been moved here with origin dev and dev, but that the origin master hasn't been up the step above. This is normal because I did not push the command, so I could not see it on GitHub for now. So what I would have to do again to do this is just push the changes. So git push origin master, and there we go. Everything should be all right. Yep. Now I go git log. We see everything is here. Git log is a command that I really like, just to see the changes like this. But this is kind of not the best way to show things for me because there are many things there. So one command I really like is just call git log and then add an option that is one line. So to have every results on one line only. So you only see like the basic ID with only a few characters, and then the commit message like this that we are using. So now let's just go check things on GitHub, and oops, not on RStudio, whatever. Let's refresh, and we can see that now both the dev and masters have the commit that was made on the branch before. So this is exactly what we wanted. All right, so the next thing we want to show you is kind of the opposite of what we just did. So this time we're going to do the merging part on GitHub itself. Instead of doing it locally as we did, merge and then get it on GitHub, we're going to do things on GitHub first. This is what we call a pull request, and it's actually an important part of like the workflow of collaborating on GitHub and everything. So first, I'm going to start by making a new change so that we have something to commit. So yeah, let's check where I am. Git status. So I am on branch masters, and I want to make that change on the dev branch. So I'm gonna git checkout dev this, and now I can make my change. So I am gonna put something here, and I'm gonna say that I make a comment for a pull request. So comment for a pull request like this. So I'm saving it. Now let's get back to the terminal. Now git status. There's a change. I'm gonna add it. We can do the -a thing here just to add everything again. Yeah, and now I can put my commit message. So commit -m for the m flag messaging, and I'm gonna say that it's a pull request commit. Actually, we like to have like action verbs and stuff for commits. So I'm gonna put an action verb, creating pull request commit. There you go. And entering this, so now git status. I am branch dev, so now I'm gonna push this down to GitHub. Git push origin dev. There you go. So now we should be on everything should be fine on GitHub. So if I go, let's just refresh this, and yeah, you can see the dev branch here that my creating pull request commit has just been made. So what we want to do is create a pull request. So we can actually click on the new pull request button here. I just click that, and then by default it asks us to. It knows that I wasn't dev branch here on GitHub, and it tells me to go to the master branch like this, and it says they're able to merge. That's normal because we created the dev from the master, and they only have a one commit difference. So the thing with pull requests here, the interface is a bit different, but this is going to be something that you might have to refer to afterwards. So you actually want to have here a title that is kind of descriptive. In this case, the commit that I put was kind of descriptive. Maybe I'm gonna add a bit more context to it and say that it's my first request, first pull request commit, and yeah, and we can also put a comment here. Maybe we just see that is, again, this is my first pull request commit. My first pull request. Oh, it's, yeah, the first pull request in itself. And here you can add comments. It's a good thing, again, to document things and details so that when you collaborate with people, everything is clear. They can understand what you're trying to do. So this is Markdown super supported. So you can actually put a few things. And like, let's say we wanted to have this in bold because to emphasize that it's your first. You can put this and preview. We can see that it's bold, it's nice. And we are just going to create it like this. Now the interface looks like this. We can see the title here. We can see the message that you made, and we can see the commits themselves that are being made. And the interesting part in this is that this is kind of like going to update. So you can create it at first and make some changes afterwards. And we're going to see there like additional changes are going to appear just back down here. So for example, if I just add a new line now in Atom, and it's going to be a second command for my pull request. There. I'm again gonna add it. I am also gonna commit it. So creating a second pull request commit. Pull request commit like this. There you go. And I'm gonna push it in GitHub. So now, if I go back here, we can actually see the thing changing and the second commit appearing. So really, like any changes that we made afterward in like this merging attempt are all going to be here, which is good. The thing we do. Another interesting feature of pull request that is very useful for calibrating is the thing that we have here. So you can put like either reviewers or assignees. So this is a way that you can tag your collaborators so that they get a notification and kind of tell them, hey, come and look at this thing. There might be some changes. I either want your thoughts of this, your help, or whatever. So I could, like, for instance, tag Gracielle or yeah, and see things. So you can assign people. They're gonna have a notification here, and they can come. They can make some changes. They're gonna all appear here. You can also make additional commands so they can make comments. So it really is the way that you can collaborate with people and is useful. Once you're done, you can just click the Merge Pull Request button. In this case, it can be merged easily. It was just 2 commits. It's going to create a new commit that is like a merging commit. So you have detail here. By default, it's going to call merge the pull request into the master from the branch. So I'm just going to confirm the merge. And there you go. It tells me to delete that it was successful, and I can delete the branch if I want. If you know you're going to work on it afterwards, you can leave it or you can delete it. If not, it can always be recreated if you like. I'm going to leave it for now. And now if I go back to the code part, I can actually see the change that was made, and I have my 2 changes here. Okay, so the last thing I want to show you for this brief demonstration is what to do in case you make a mistake. You've actually seen me make some mistakes here. And of course, they can happen when you work, when you make some changes, when you do some commits and everything. And there are a few ways to change that. I'm going to show you the one, well, that is the basic, that is called reverting. So just when you make bad commits, you revert it, and by creating a commit that is going to cancel the first one. So let's do this. Now going back to Atom, I'm just going to first check where I am, on which branch, just to know. Okay, I'm still on dev, so this is fine. Going back to Atom, and I'm going to put bad commit and get a letter because this is bad. So this is a bad commit. Right. Okay, so I've just made it, and now I am going to, of course, if I check for status, there's the commit. I can just add the thing, the README, enter, I inked it. And now I'm raising my message that this is a bad commit. Okay, and now we've made the commit, and if I run with the Git log, let's put it in one line, I can see that it's in the history here. But when we try to revert it, sometimes we might even want to revert something that has been pushed on GitHub. So I'm going to do this. I'm going to push it. Actually, put origin dev there. And now when I go back on GitHub, update this. It's not there yet. Did it work? Yeah, of course I don't see it because I'm not on master. I am on master and I'm not on dev, which where I did my change. So I can now see my bad commit, capital letter here. So now the problem is that the bad commit that we have is like public, is on GitHub, and some of our, like my collaborators, for instance, might have pulled that one and like downloaded it locally. So the thing is, this case, I want to do is revert the commit. And with the log, remember, I showed you there was a commit ID. So this is the way that you can identify the bad commits that you've made. So here I see that it's this one. So this is the case where I'll need to use the thing that is here. So I'm going to try to select it because it's a bit complicated. Yes, there you go. And then I'm going to copy paste it. So I get out of this. By the way, to get out of this, when you have double dots, you just type the Q command. And I get back. And now, yeah, I'm going to apply the revert. So now we get revert. And here you put the ID of the commit you want to revert, like the bad one. So in my case, it was the other one. So now I am just going to paste it here and run this. So yeah, right now, for brief one, we said it was asking for something to be closed, and now we have this. So this is kind of like, it's called Vim. It's the built-in text editor that comes by default with Git Bash. So the thing it asks us to do here is just to put the commit message for the reverting commit that we are doing right now. So by default, it's revert and the message of the previous commit. So this is fine. It's actually what we want. Here is the description. We don't really have to care about that. We like this. And we're just going to get out of here. Oh, actually, I made a mistake. This is not Vim. This is Nano. It's the other editor that is built in. And here we can see this means that to get out of this, we have to do Control X. So that's what I wanted to do. Right, I got it out. And now if I run git status, of course, it's fine. And if I do git log, I can actually see that there's a new commit that was made, the one that is revert a bad commit. Here, the bad commit was here, and now there's the reverting one here. Let me just show it again, but on one line. There. So we can see that the bad commit was pushed on GitHub, and now the new one is here, and everything is fine. So if I now look at my atom, how it is, the change has been canceled. It's not there anymore. So this is actually what we want. So what we have to do to fix our problem right now, it's just to push it back. So now git push origin dev. And there we go. We should have it online. Refreshing this, and the commit has disappeared. We have the revert commit right there. So we have made a mistake and learned how to fix it. Okay, so this is all we have for this demo. I hope you enjoyed it, that it's useful to you. We will put some links in the description, such as the one of software carpentry and how to install Git on your computer. And we might put a few things there as well. So just look at them if you like. And if you have any questions, people from the Data.trek, feel free to contact us. We will be there to answer your questions. We love Git, and we'll be happy to discuss about it with you. So that's all, everyone. Thanks for listening, and see you.